Good afternoon, everyone. Welcome back after lunch. Hope you all had a good lunch and now full with energy to ask tough questions to our panelists today or be interactively involved. My name is Jari Kauppila. I'm the head of Secretary General's office in the International Transport Forum at the OECD, so a Paris-based intergovernmental organization. I have a very huge pleasure to moderate today's session on a very important topic, visuals for understanding analytics. And we have two speakers here today for 90-minute session. So we have good time for discussions and comments and hopefully a very interactive session as well. Just before you wonder what a chief of staff of an international organization does here for Visualization Symposium, I should add that I've also headed the ITF's quantitative work and visualization, analytics, and statistics. And in that role, it's really a pleasure to be here. So let me turn right away to our first speaker. It's Linda Lim. I need to look my cheat notes here. She's a National Science Foundation graduate, research fellow from the University of Virginia, getting her PhD in civil and environmental engineering. And she also works full-time as an ITS engineer out in Las Vegas and Henderson, I think both in Nevada, if my geography of the United States is correct. Great. I did think that your one point about this is very important, is that you're a daughter to Cambodian refugees, and you're the first in your family to graduate with a degree in engineering. So it would be very interesting to hear your presentation on using real-time citywide datasets to generate artificial intelligence solutions. A case of Henderson, please.
Hello, everyone, and thank you, Jari, for the introduction. My name is Linda Lim, and I'm an ITS engineer out in Las Vegas, Nevada. And today I'll be talking about the work I did with Ludian, in which we utilized their real-time citywide data sets to be able to come up and generate artificially intelligent solutions for the city from a transportation perspective. So to preference, I'm going to say that the work that we're doing is still ongoing. So we're still developing it. However, I do think it's important to talk about the initial process and the initial phases that we did with the city of Henderson in working and building with this AI. So just to go over the outline of this project, I want to talk about the existing problems that we see that are common today. And how can we use big data to make it intelligent? So big data is everywhere. There's more, as technology advances and we see more and more of it, are we actually utilizing big data to make it more intelligent and work for us? And also, the initial process, as I mentioned earlier, of discussing these roles and what we had to do with the city, working with the city, and building this. How we use big data to also enhance work zone management, as well as using data to enhance EMS response times on our network. And then kind of showing the overview of what we have so far of our dashboard analytics. And then going over the challenges and the lessons learned that I think are important to kind of go over. That way, in case your jurisdictions or your agencies, you'll be able to kind of foresee and forecast and hopefully learn from the mistakes and challenges that we dealt with, as well as going over any recommendations that I have from you and some key takeaways for this presentation. So going over the existing problems that we see today. So as transportation professionals and engineers, one of our biggest concerns is traffic fatalities and accidents on our roadways. Many of you are familiar with Vision 0, so we understand that we want to design for roadways to have 0 fatalities on our roadways. And so also to add with that, traffic delays and congestions are also another problem and an issue that we're wanting to mitigate as well. Anytime there's accidents on the roadways, there's lane closures, and so we want to be able to utilize data to make it intelligent and work for us, so that way we can mitigate these congestions much more efficiently. And so add to that, are we heading to Vision 0? So according to the NHTSA's National Center for Statistics Analysis, they recently came out with this chart showcasing the fatalities from the year 2011 to this year. And in 2021, we see a 17.8% percentage change increase from the previous year. And definitely within the last 3 years, we know that COVID had an effect on us because with the lockdowns and everything, we weren't really allowed to travel as much. And so what the statistics shows is even though we weren't traversing as much and traveling as much, whenever we did travel, we would have much higher accidents and fatalities happening. And so you could see here from 2011 to 2020, or 2019, the traffic fatality rate is 1.01 to 1.13. And in just the last 3 years, it went up to 1.24 to 1.30. So are we really heading to Vision Zero? And so that's a question that we should be concerned about and think about. So some existing problems with work zone management that we currently see today that are some common problems on the roadways. So these are two pictures that I took. On the left side, we see Las Vegas Boulevard, and on the right side, City of Henderson. One of the biggest customer complaints that we get from residents are all the barricades that are on the roadways that people telling us like, hey, you know, we see these barricade cones on the roadway for a long period of time. Like, why are they there for so long? And when are they gonna be done? So it's just about being able to collect data to be able to track these things and be able to optimize solutions so that way we can be more efficient with when and how long these barricades are on there for. So we have to ask ourselves, is there a better solution? And how can we use our existing data to enhance safety in addition to creating more efficiency? And so that goes into my next point is how we can use our data to make it more intelligent for us. So here's just a data visibility pipeline that I kind of blew up myself from a transportation-related perspective. This is kind of a common diagram that software engineers show for a dashboard. And so the idea behind this data visibility pipeline is to be able to come up with a dashboard that indicates and shows all the accidents and hazards that are on the roadways, that indicate all the malfunctions, and essentially pings the traffic management team, hey, you should focus on these areas of our roadways. In addition to that, also being able to train the data so that it can eliminate duplicates and any errors, thus optimizing and having better data, better quality data. So some of us may be familiar with the advanced technology management systems that are on the roadways, also known as ATMS, which is essentially the dashboard that shows, you know, the EMS resources, the real-time scheduling and navigation, as well as indicating the major events that are happening on the roadway. And so to get it to become artificially intelligent, what does it need? It needs to be able to predict and forecast. So this comes with machine learning. So being able to take this data that we have on a single platform, but then also being able to have these data sets predict and forecast using machine learning algorithms to eventually be able to make decisions for us. And so going over the initial process of what I mentioned earlier, what I think is important to do before building anything that's related with AI, I think it's important to come at it from a systems engineering approach. And so what I mean by that is coming up with a higher scale of what their data goals are, the purpose and the ethics as to why we're doing and why we're building this in the first place. As engineers, you know, we're definitely trained to go to school to figure out solutions. And sometimes questions that we forget to ask ourselves is like, should we build? And so having the systems engineering approach is very important to establish not only within your industry, but also with government agencies as well. So it's developing data goals, identifying what the challenges are, doing a systems audit review, and being able to build a system architecture, in addition to creating key performance indicators, doing a gap analysis and needs assessment, as well as providing the functional specifications to build out this platform. And so here we have the system architecture diagram that we built for the city. This breaks down each of the departments, as well as all the systems that the city utilizes. Why this is important and very crucial to this step is it shows the relationships of all the systems. So these are all the systems. So you have EnerGov, ArcGIS, then you have the purposes behind these systems. So city attributes, the fleets, the EMS services. And from here we can see the connection throughout each department. So whenever you're building out this system, it's important to show the relationship not only between the systems, but also the department that utilizes these systems. In addition to that, I also think that it's very important to lay out the relationship between all the systems and how the data flows between each system. So on the left side, you see the traffic controllers, the traffic control. These are the systems that are connected to the traffic controllers. So we use the FLIR detection, pedestrian detection, and EMS, for example. A double arrow indicates data flowing through both ways. Single arrow indicates data flowing through one way. And why that may be important is understanding the data flow allows us to be able to build the algorithm so that we have a better understanding of the architecture of all the systems and their relationships between users and systems. And so I'm going to be talking about how we use data to improve work zone management. So that's me on the left side. That's me pretending to be a construction worker on the job site with my orange vest on there. But we built the app where essentially, as I mentioned in the previous slide of the barricades being on there for long periods of time, we wanted to be able to have a way to track the barricade setup and tear down times. And so how we can do this is going out on the job site, having the worker, for instance, me in this case, log onto the app to indicate the existing bookings. So this is kind of what you would see on the phone. So you would log in your permit information, which contractor you're working with, and then also the planned setup time that you're supposed to be there, as well as how long it took you to set up these barricade cones. And so what this does, it relays information to the traffic management center in real time of how long these barricades have been up there, and also be able to make the connection between the construction worker on site and the traffic management center, which sometimes gets forgotten because departments work in silos. So this kind of just allows a way to make that connection between contractor and traffic management center. And in addition, they can also log in information on the job site, such as how many lane closures there are, sidewalk closures, bike closures, as well as whether or not the traffic signal has been impacted or the transit signal has been active. So this kind of information allows the traffic management team to be able to see and assess which roads and where the intersections are heavily impacted. That way they can best mitigate these issues. So this is just showing the data flow of the app. So you log onto the app, then data flows to the dashboard, and it indicates green if they're on site, yellow if they're less than 15 minutes of planned time, as well as red if they have exceeded the planned time, and then data flowing back to the database to the department architecture or department dashboard once they are done setting up their barricades. And so why this all is important is, as I mentioned, it establishes a working relationship between the contractor and the traffic management team, which oftentimes gets neglected. And so my other point is how we utilize data to enhance EMS response times. So FHWA, ITS architecture, put out this data flow chart in their recommendation for how the data flows between each of the agents. And so here we have the vehicle services, EMS team, which relays information of the incident statuses and emergency dispatch to the police and fire department. Then we have the traffic management team, which relays information about the current network conditions to the safety management, as well as the transit management team relaying information about the transit status. An information service provider, which relays information about the road weather to the safety management team. And so going over the data connectivity needs that are required for building EMS systems and being able to utilize the data into our dashboard, we have the signal controllers, which in the case of City of Henderson, they utilize GTT Opticom, which relays information to a cloud that is connected to the EMS vehicles right here. And all this information transmits data that figures out the best route and the optimal alternative route in case there's heavy congestion. So what we found when we did this investigation was that there is data issues. And so the data issues was the network grade communication. And what I mean by that are certain intersections were not fully connected with one another. So ideally, you would want to have all the intersections connected to GTT Opticom so that way they can pick up the signal for the EMS service. That way, each intersection communicate with one another when a signal has been picked up by the EMS system. What we also found was part of the data issue was certain areas being 4G fiber optic versus 5G. Now, majority of the areas are 5G fiber optic nowadays. However, we noticed that some areas were 4G. And so what this does is it causes a signaling issue where data wasn't able to be picked up by the EMS vehicles. And so not having signal means that not having data that is really important for building the system. And so through that, it made it so that these traffic recovery rate was much slower than expected. So how can we solve for that? Well, recommendation is to have all the intersections connected to each other. A common issue that we found is with some cities, city planners and municipalities will hire vendors to supply these systems onto their intersections. But depending on the vendor, sometimes the vendors are not in the local area, so they'll just install these devices on there and potentially not configure it correctly or not manage it or maintain it. So just being aware of that is very important when it comes to building out this system, knowing how the whole process is, who's in charge of actually maintaining the actual devices that are on the intersections. In addition to that, ensuring that there's uniform 5G optic network throughout the areas. And through this, we'll be able to utilize real-time data to relay vital information to Traffic Management Center. And so this is the AI dashboard analytics, where this is kind of the idea of what we're trying to achieve. So essentially, pulls up all the information in real time, all the systems that the city uses, GIS, Strava, to name a few, and then also an ATMS system put onto a single platform in which they're able to relay information from a vehicle standpoint, speeding, being able to see and visualize where the areas of speeding happen, as well as pedestrian detection. So as I mentioned earlier, this is still in the development phases, but this is the first initial phase in which we were able to develop specifically for speeding. And so now I'm going to be going over the challenges and the lessons learned with this project. So getting complete data visualization insights was one of the challenges that the city has expressed. You know, part of the problem is we utilize all these systems, but we're not really unsure how these systems are all interrelated and connected with one another, how the data flows. And so data is not really useful if it's just sitting in a cloud. And so part of this data visualization conference, or what we're hoping to achieve, is utilizing data that's sitting in a cloud, putting it in a visual graphical display, and then ideally being able to optimize it to make artificially intelligent solutions for us. Another issue and challenge was the connectivity of the data. So as I mentioned earlier, some areas being 4G versus 5G, and then also some intersections not being fully connected to the supply. In addition, obtaining quality data, so sometimes in police crash reports, each policemen they're humans too, they're not gonna enter data correctly. So part of being able to sort out this data is having a system that filters out these issues and duplicates and errors. And another thing I kind of glossed over was working in silos was also another challenge. So with each department, they work day to day in their office and are given tasks, but sometimes they because of the whole working environment, they're used to working within their own department. And so we also found this like a bit of a challenge when it comes to asking around of how these systems are all interconnected. And so going into my recommendations, oh, why is it showing it like that? Okay, there it is, okay. So my first recommendation is As I mentioned, we have agencies working in silos, and to be able to have that interagency collaboration with one another, which takes from a reactive approach to traffic management to a proactive and predictive approach. And how we can start with that is building a systems architecture, as I had showed previously, where we break down in a visual representation of all the departments and all the systems that are working together and how they're all connected, and then being able to build out the data flow between each of these. And from there, you can work out the algorithm to come up with the dashboard analytics. And so my third recommendation is going from a reactive approach to traffic management to ideally a predictive approach which handles AI. But in order to get there, we have to be proactive. And to be proactive means, for instance, as the example I used earlier with the EMS, figuring out why are these intersections not connected to the system? Is it the supplier issue? Is it a vendor issue? Or is it traffic management? We don't know. And so it takes having that proactive step to figure out these things when you're building out this platform. And so I'm going to conclude with some data quotes, because I like quotes. One of my favorite ones that you might have all seen if you're a researcher, all models are wrong, some are useful. And the other one is AI algorithms need to extract pertinent facts, and the platform should enable the user to go from a micro picture to a granular analysis in one click. And with that, that's my info. Thank you all for attending my session, and hopefully you all gained something or learned something from my presentation. Thank you.
Thank you very much, Linda, for the presentation. I think it highlighted one of the points that is always interesting to me is that when you talk about visualization or any work on data, you start facing problems first. But by doing that, you're already solving some of the problems along the way. So just the work it starts already sort of improves things. And the other thing you mentioned, using the data as a connectivity, connecting different actors and different stakeholders. I thought it was interesting as well. I open the floor for any questions you may have, or comments or thoughts. Michael.
So I know you say it's still in development, but can you go back to your visualization? I think it's slide 22.
Yes.
Can you just explain what a few of the things on the screen are, what they're meant to represent?
Yes. Let's see. Yes. So, there's a mouse right here. Okay. Yeah. So these are just the indications. So these are the roadways, and you could ideally. So this is just for speed for right now, and so here we have the variations in different speeds and how long that they're going for, which gives you a measure of that. This also shows you the time of day in which these speeds are occurring, indicated in yellow, red, and blue. And so it's just giving you a way to be able to measure, spots of speeding. And so right now this is only showing just a segment of the road, but right now, ideally, we want to be able to have it for the entire city. And so we also showcase the speed range here as well. Sorry, I know I went kind of past the slide rather quickly, but if there's any other questions.
While everybody's thinking, maybe one question from my side, two questions. The first thing is, I wasn't quite sure if I was correct. Who are the end users of this analytics? Different actors?
Yeah.
In your view, is there a need for educating the users? Putting that in front of someone, it's quite intimidating.
Oh yeah, for sure.
Did you get any feedback on how to use this data? Any challenges?
Yeah, well, we haven't gotten to that phase yet where, since we haven't finished the product to train, but similar to other applications, like I know SynchroGreen and TrafficWare, once they put out the product and they've installed it, there's a training session that they have with all the city workers who utilize the software. And so depending on how in-depth the training is, that can go from a few days to a week. So when implementing this product, depending on which users or which departments will work on which system, What we want to do is we want to have all the departments utilize a single dashboard, as opposed to, sometimes the department will be like, oh, well, traffic management will only handle traffic and that's it. And city planners will only handle this part. But we want to be able to bring all of those components onto a single dashboard, so that way everyone has that understanding. And so to do so, we would have to train each department for all the areas, whether it's planning, whether it's traffic related, and also getting together with the City of Henderson Police Department as well too, because initially, before, there was no communication or working relationship from a data perspective. But now that we're pulling in data from the police department, we would have to establish this working relationship and have training them too how to utilize this dashboard, because they would be able to get information from this dashboard as well.
Any other questions, thoughts, ideas that the presentation might have raised in the minutes?
If this is speeding data, and I might have missed it, do y'all have cameras that are determining the speed of the cars in real time?
Yeah.
Are they doing electronic citations right now?
No, not right now yet. That would be up to the police department, because that's probably not in the realm of traffic management team. I think that's up to the government agencies of how they want to distribute traffic citations. But I know that speeding has been a key point that the City of Henderson wants to solve, being able to see which areas have high cases of speeding. Yeah, so that's a very important point that you made, because the initial process, this section right here, I mentioned this, doing it from a systems engineering approach, and part of the systems engineering approach is establishing data goals. And we didn't just do this with the traffic management team, we actually sat down. So every single system that you see here, we actually sat down with each department and talked to each of the people working in those departments, how they utilize each of these systems, what data does it pull, where's the data source coming from, what malfunctions and what deficiencies are they currently experiencing, and then from there, logging it into the audit. So that's this part right here, conducting a systems audit before building out the architecture. It's kind of doing this investigative work, going to each of the departments, because we weren't familiar with the systems architecture as well. They essentially hired us to do this work, and so it took us sitting down with each department and asking them which systems that they use. Some systems were shared between each department, so we jotted that down. And through the systems audit, then we were able to proceed with building out the systems architecture, which is this part right here. Yeah. Yeah, no, actually, so when we came out with this, they were like, wow, this really helps a lot, because their biggest complaint was they wanted to be able to have a visual representation of all the systems that they're using. It's like we have all these systems, but we don't know how to effectively be able to utilize it to their best of the capabilities. And so once we started drawing it up like this, they're like, oh, this is a lot clearer for us to be able to see how the systems are connected. In terms of the architecture diagram, they're like, oh, we know how all the systems work now, because, for instance, if you had asked the Department of Public Works, how does, Maximo and Energov work, which are the city permits and work orders, they would have no idea. But having this laid out, they know which department to go to for that kind of information. But it also helps us too when it comes to building out this platform, because once we have an understanding of how the systems are all communicating with one another and how the data flows, then we could build out the dashboard that I had showed earlier to be able to provide us with the information, which I want to emphasize, I think, is the most important part throughout this work. Not only just building out the dashboard, which is the end product, but to get there was the hardest part, doing the investigative part, which is showing the data flow from each of these systems. That took a bit of work to understand their relationships with one another, as opposed to just, I think this program works here, and then just building that platform. But then you have more issues if you just kind of tackle the problem without knowing the root problem.
Let me use my prerogative as moderator just to ask one more question. Is there a plan to make some of the data publicly open for users of the roads instead of the agencies? I'm thinking disruptions and planning and predictability would be extremely important for the road users.
Yeah, that's a good question. As far as their answer to that, I'm not sure because I haven't spoken to them about what their intentions are for using it, but at the moment, I know that they're interested in using it within their realm.
All right, thank you very much, Linda.
Yeah.
So next, we are very pleased to have Michael Platt. I will need to use my cheat notes again for his bio. I'm sure many of you know him already. He is the director for the R&D team at the University of Maryland Cat Lab, and I have to look for what CAT stands for. Actually, I do not know. I don't even know if you use the word CAT or SAT or CAT. CAT. So the Center for Advanced Transportation Technology Lab, and to make transportation data more readily accessible and usable for transportation officials and researchers. So, Michael, the floor is yours.
All right, thank you. So whenever I give a presentation, I'm usually talking about something that we're doing with our RITIS platform. And I usually focus on, traditional probe data from commercial vehicles or passenger vehicles, or I might focus on some safety data or maintenance data. I rarely, however, talk about what we're doing with connected vehicles. And that's what I'm going to be talking about today. Now, I say connected vehicles, but it's also connected vehicles and mobile devices. So anything that provides some sort of a location about it. Now, this location data can include the real-time movement of things. So each one of these dots, you can barely see it up here, is an actual vehicle that was coming into DC at a particular time. Connected vehicles can give you other types of information as well. They can tell you whether or not someone's slamming on the brakes at a certain point in time, or whether or not the windshield wipers are on, or the vehicle's rolled over, traction control is engaged. In some cases, you can even tell how many people are in the vehicle from the sensors to figure out if the seat belts are buckled and all that sort of stuff. So there's all sorts of information that's in there. For purposes today, though, I'm only going to be talking about the positioning of the vehicles. Where are they at a particular point in time? And where do we get this data? There's lots and lots of different data providers that are out there. You probably know many of them. I think one of the more unique ones that most people don't know about is the US Postal Service. They have vehicles all over the place, driving pretty much every road every single day. And not only do they have just their traditional latitude and longitude points every second or so, but they also have really, really high frequency, like 10 hertz measurements from, what are they called? Not gyroscopes.
Accelerometer?
Yes, accelerometry data. So you have, the movement, the shaking of the vehicle, and there's all sorts of cool things you could do with that, right? The drivers sometimes wear those, and when they walk to your house, you can see them walking across. You can theoretically tell whether or not the driver has a medical issue, because they might be, starting to limp, or their gait changes over time, or you might be able to tell if someone needs their lawn mowed because they're, walking a little bit differently through the grass. There's all sorts of neat use cases that you can get from this data. I'm not talking about any of that today. I am talking specifically about people movement. How do people move through a particular region during a particular point in time. We've been doing this with connected vehicle data for quite a while, but it really picked up during the pandemic, where we put together a COVID impacts dashboard where we wanted to track people moving throughout the entire country. How far are people traveling? Are they going across a particular border? Are they staying at home? Are they social distancing? Are they going to places where they might be importing the virus? All that sort of stuff. So we started, visualizing data there. We'd already put together a basic trips analytics platform for these types of data for our state DOT partners, but then we started to add things to it, what we call our next generation trips analytics platform. I'm not going to train anyone on how to use it today, but I'm going to show you a couple of use cases for this tool. The first one is for the Great Smoky Mountains National Park in East Tennessee, western North Carolina. The National Park Service really wanted to understand how people are getting into the park. Once they're in the park, where are they going to? Because they have a lot of traffic problems in the park. I think it's still the only national park in the country that is free to enter. So you got a lot of people going there. It's a big park too. So what I'm showing you here is a screenshot from our tool. I've gone in and I've said, hey, I want to do a study for the state of Tennessee. And so first the application goes out and says, okay, for the state of Tennessee, grab all of the trips that touch the state of Tennessee during, their travel. So that could be a trip that started in Tennessee and ended in Tennessee. It could be a trip that started in Tennessee and drove down to Disney World. Or it could be a trip that started, somewhere up here and traveled down through Tennessee to go to Disney World or whatever. Any trip that touched the state of Tennessee is a trip that's in the Tennessee data set. Right here. And then you go in and you start applying all sorts of filters, like what type of trips do I want to look at? Do I want to look at passenger vehicle? Do I want to look at freight trips? Do I want to look at boat? Do I want to look at pedestrians, bicyclists, whatever? And what region do you want to explore? So I wanted to look at the Great Smoky Mountain National Park. So we've drawn a little polygon here that represents the border of the park. And if you look down here, there's some buttons you can press. And I've specifically said I want to look at any trip that started outside of the park and ended inside of the park, or that started outside of the park, went into the park, and then came back out. Those are the trips that I care about. That's the trips that the Park Service cares about. So I click those buttons, and then I chose some date ranges. And I want to start off by looking at the July 4th holiday weekend in 2021. And I said, for any trip that goes to the park, that's the park right there, where did they start from during this weekend? And I just looked at county level data. You can go, finer granular if you want that. But you can see the darker zones here. Those are where more trips began. So it was like close to 15,000 trips that came from the neighboring county into the park. And there's some people that came from a long way away just to drive down the park for that weekend. If we progress further, doing a deeper dive, we don't want to just know where people are coming from when they get to the park. We want to know, how are they getting into the park? What entrance are they using? So now I've drawn the park boundary again, and the tool automatically finds all of the crossover, the entrance points into the park. All these little dots are how you can get into the park. And then these other polygons that have been drawn in here, these are places of interest within the park. So, this down here is a place called Cades Cove. There's other places where there might be like really cool hikes, lookout points, or a ranger station, or a campground, or something like that. Well, the Park Service wanted to know something about this. And so again, we said, let's look at a particular date range, let's look at how people get into the park, and we specifically wanted to look at origins. So, how did people start their trips, where they come from, and it gives us percentages of where all of these trips began. You can see that very few people are entering from the east side of the park. Most people are coming from the Tennessee side of the park up here. Here I've clicked on a, this is the destination. So once they enter the park, where are they going to? What percentage of people are going to this zone versus some other zone? And because I said I want the trip to start outside of the park before it goes in, most of the trips are ending a relatively short distance inside of the park. That happens to be where the big visitor center ranger station is. Some people who are in the know just bypass the visitor center and go on to other places. You see there's a fair number of people that go there as well. You can also then click on any one of these zones, and when you click on a zone, it then tells you, okay, for everyone who went to this location, here's what percentage used this park entrance versus this park entrance versus this park entrance over here, percentage or actual number, whichever you want to see. And it'll tell you that. But we wanted to dive even deeper than that. So then we said, well, let's not just look at the border of the park. Let's go out from the park at least a county away in all directions. So again, this zone right here, that is the park. And then these are the surrounding counties and zones. And then all these little dots, those are the entrance points to get into those counties. And what we wanted to do this time was understand, again, how people got to the park, but which roads did they use in the surrounding area to get into the park. So we run a query, and the query comes back with a list of all of the routes that people took and how many trips were on each of the individual routes and what the length of the route is. And then there's other stuff hidden behind this drop-down box that tells us like the travel time and the reliability and all that sort of stuff. And I said, well, I want to visualize any route that had at least one trip on it. Pretty basic stuff. So that's what all of these orange lines are. At least one vehicle, one person was traveling on one of those orange routes to get into the park. You can put your mouse over any one of the orange lines, any part of the orange line, and it will give you some additional information. It'll tell us here that 98 of all of the trips that are in this data set cross this one little point that I put my mouse over, which happens to represent about 3% of all of the trips. And then if you click on that same zone or that same link, then it highlights where people that crossed over that little spot, where they came from or where they went to afterward. That's the blue line now that's been highlighted. The other thing you can do is you can zoom into a spot on the map and you can draw what's called a screen line. So I used my mouse and I drew the screen line just across this area right here. And now it tells me for everyone who went into the park, what percentage of the trips crossed that particular spot where I drew the line. So it's hard to see the numbers, but up here, 41% of all the trips came right across that particular zone, that gate right there, whereas 33% came across over here and far fewer in all the other locations. So those are the two primary routes that people seem to be using to get to the park. And then just like we did before, you can click on any one of those crossover points, and then it highlights all of the routes that people took after they crossed that particular spot to get to the park. And you can see some people came down and went immediately into the park and then exited the park. Other people came down and then they said, well, we're not going to go in this direction. We're going to go around and we're going to, check out Gatlinburg or Pigeon Forge, and then we're going to come into the park. And you can see how people move about in the area. You just keep clicking around, you can start to bring up all these different insights. And as you click on a particular route, it then will highlight that route up in the top and give you the travel time statistics and reliability statistics up there as well. So that is a basic planning use case that the Smoky Mountain National Park folks are now using to try to understand how people are moving throughout the park. The next use case I'm going to show you is more of an operations use case. So you're in an ATMS, or you're in a traffic management system, you're using your ATMS, you're trying to manage traffic and deal with crashes. So we are specifically going to look at a crash that occurred on I-95, which is this road that goes from, Florida up to Maine, I guess. But this is I-95 right here. The crash occurred right where this arrow is pointing, just south of Baltimore. It closed all of the northbound lanes for, about 4 hours. This is just how the incident was managed, how the lanes were. This is a timeline of the incident. So the incident started at 2:45, that's 6:45. These are all of the agencies that were called to the scene of the incident and when they were on the incident, what they were doing, a lot of tow trucks. This is the lane stats. So the lanes were pretty much blocked the entire time, and then they opened up right at the end. Here's a picture of the crash taken from a helicopter overhead. You can see it's pretty bad. So what the operations folks want to know is, okay, we have spent a lot of time figuring out if there's a crash in this location, this is the detour route that we want people to use to get around this particular crash. They have all these signs that they go and they put out in the field. They've retimed the traffic signals to make it easier for people to get around the crash. Are people actually using the detour route that they want them to use, or are they making it up and doing their own thing? So using this trips analytics tool and the data behind it, you can draw spatial filters. So the crash is right here. I want to understand how people move from kind of, Virginia, DC, up and through the I-95 corridor. So I set a little filter. I drew a polygon that's going to capture anyone that drives through this area. So this is going to capture anyone going east on 50, anyone going up 295, anyone going up 95, Route 1, Route 29. All that traffic is right there. So you have to go through that gate, and then I want to capture all the trips that go out here. So this will capture anyone who continues up through 95, 83, going out east to go around, Delaware. It's capturing all the trips generally. So that's my spatial filter. And the first thing I did was I said, let's look at a normal day when there was no crash on the roadway. So this is the normal day. All the blue lines and orange lines are just routes that people took. I clicked on 95 just to highlight anyone who crossed through or used I-95. These are the different routes they might have taken. And then I drew a screen line. Drew a screen line right here, and it's probably hard to see, but it's showing that about 62% of all the people were taking I-95 at this location. 28% were going out east on Route 50. So that's a normal day. This is the day the crash happened. So we went from 62% of the traffic on I-95 at this location, dropping to 36% traffic. A whole lot more people are going out east and going out out towards Ocean City, and they're probably going up through Delaware to get around this. Some people are going west on 29, and there's a few other alternates. But that's a long way away from the crash, right? The crash is way up here. So I'm looking at data down here. This is just a comparison, the day the road was open, the day it was closed. You can see the percentage breakdown. This is looking closer to the scene of the collision. So the collision again is right here. And so we can see when we get right close to the incident, normally 81% of the traffic would be using 95, and far less going to the east, and 7% going up to Route 70. On the day of the crash, of course, 0% is now getting through I-95 because the road is closed, and we see 23% of the people are going up to I-70. 17% are going all the way down here to, I think is that 295 or Route 1? I can't remember what that is. Anyway, so what State Highway realized is this is not how we expected traffic to behave. And by the way, I forgot to mention it, but I ran a filter and I said I only want to look at freight. I just want to look at the trucks. And a lot of the roads that people are taking to detour around this are not meant for trucks. There might be safety issues, there might be issues with the width of the road or the clearances and all sorts of other stuff, or the road just might not be designed to handle it. So State Highway Administration has a messaging problem. They need to reach out, they need to do a better job of telling people what routes to take, or they need to beef up these other alternative routes so that they can handle the truck traffic. But this isn't the whole story. When people get off of the main line, they're getting onto arterials, and arterials have traffic signals. So what's happening at these traffic signals? What's pretty cool about this is since we're getting the location of these vehicles every few seconds, we can actually see how they're moving up and down individual corridors. So this is like a full corridor right here. This is just the northbound traffic. This is just the southbound traffic, but you can see them meeting in the middle. Because we see them, their position every couple of seconds, we can actually figure out if people are getting stopped at traffic signals, whether they're turning left, turning right. There's all sorts of cool stuff you can do here. And without having to install any infrastructure on the roadway at all, you can now see whether or not the signal is performing well, just with connected vehicles data. So if you imagine this is distance on the road, this is time. If a vehicle is pinging and moving down the roadway in, pretty much a straight line, that means it went right through the intersection. It arrived when it was green. If it gets stopped for a short period of time, it arrived on red, and then it'll continue. If it gets stopped twice at the same location, you have what's called a split failure. Someone got stuck at this light for at least 2 cycles. So that's a problem as well. So what we did for this particular crash is we used this same connected vehicle data to take a look at the detour route that State Highway wanted people to take right here, Route 1. And there happened to be 3 traffic signals right on this detour route. So people are getting off of the road, they're coming down here, and people have to turn left. So let's look at this one traffic signal. How are people turning left right here? This is a normal day and how long people would wait on average to turn left during the 2 p.m., 3 p.m., 4, 5, and 6 p.m. hours. This is the day of the crash. And we can see that on average, during the day of the crash, people are having to wait, 2.5 minutes right here to turn left compared to what they would normally have to wait. And same thing in the 6 p.m. hour. That's turning left at that intersection. We can also look at the people that weren't turning left. They're already on the road. They're just going straight. We can see that this crash and people getting on the arterial impacted them as well. They had to sit and wait at the intersection a lot longer. Maybe this is acceptable behavior, maybe it's not, but now State Highway at least knows what the performance is, and they can go out and they can study it and figure out whether or not they should actually retime the signal. And the next time there's a crash, and there will be a next time, they can then look at the data again and see if their changes had any sort of an impact or not. And so those are a few examples of how we're trying to use this connected vehicle trajectory data to analyze people movement, vehicle movement for planning and operations. That's all I got.
It's another excellent presentation showing the wealth of information you can have from this type of data. Please, any questions, comments, ideas to like?
So I love VIZ. I use it all the time. Is this available right now for us to be able to use, or is it still?
It's available right now for people that are paying for that data. So the data behind these tools can be expensive. Depending on the date range you want to look at, depending on the data provider that you buy it from. We don't really supply the data ourselves. We do the analytics on top of it. But there are dozens of states that are using these today.
So for instance, I have access to VIZ through Nevada. So would I be able to have access to this one as well?
I don't think the state of Nevada is funding or buying data for this. They're buying like the speed probe data and that sort of stuff. But if they change their mind, we're here to help.
Open invitation to get the data.
That's right.
Any other thoughts, questions, please?
Are you expanding the data anyway, or it's just whatever is coming from these?
Great question. We don't like to change data once it comes to us. So if the data supplier's data looks like crap and is crap, you'll see it in our visualizations. And some of the visualizations we've produced will definitely show you that. You know, in fact, we saw in the early days of this one data provider, if you started to view the routes, some of the routes didn't make any sense at all. And the data supplier was getting like train track, you know, there was train tracks going alongside the highway, and we were picking up people on the train as opposed to people on the highway. And, you know, the tools show you that sort of stuff. We're not factoring up the data to be representative of the entire population. That's, you know, on you right now. But yeah, we don't do a lot with it other than expose it and make it easy to work with.
If I may continue that question before handing over, I was about to ask about representativeness of this data. It depends, I guess, a lot between the states, or
It depends on the provider. Well, it depends on the provider and the geography, right? So, you know, rural areas aren't going to have as much data as urban areas, of course. Percentage-wise also depends on the data provider. And you have to be really careful with how people describe their penetration rates. So one data provider might say they have 50% of all the population covered, right? Another data provider might say I have 5% of the trips covered. The 50% coverage might not be better than the 5%, depending on how they're calculating that. So 50% coverage might mean I, data provider, had a ping from 50% of all the cell phones in the country or in a geography at least once during the month of X, as opposed to getting consistent pings from a cell phone every minute of every day. That might be, you know, the 5% data provider. So just when you ask that of the data provider, make them explain how they come up with their numbers, because it may not make any sense. Anyway, back to your original question. I really showed two different data sets during my presentation. I showed a trips data set, which lets us look at people moving all around the country and looking at routes and stuff. That data has a higher percentage of coverage than the data we're using for the traffic signal data. So traffic signal data, I really need to know the position of a vehicle every 1 to 5 seconds. I have to see it slowing down at an intersection. Whereas the across the state, across the country travel data, maybe I need to only see it once every minute or something like that, and I can impute the route that's in between. So those were kind of different data sets. And there's certainly fewer vehicles that are giving us their pings every 1 to 3 seconds than there are giving us every 1 minute or something like that. I think one use case was Enrix. I think another one was might have been a mix of Wejo and Geotab. I don't remember. The signal application I showed you was definitely Enrix data, which is sourced from Wejo and several other providers. They do, but they also have, yes. And so, you know, that's another thing you ought to think about when you're reaching out to data providers. Find a data provider that has lots of sources, because if you find one that only has one source of data and that source dries up or changes, you know, your trends are thrown off, there's all sorts of problems. But you want one that has like 10 to 50 different data providers if you can find it.
You mentioned that there's like a planning aspect to what happens when a crash occurs, and there's a change to the signal timing potentially. sequentially? Is that like that? So you're comparing the normal signal timing to this other timing method in response to a crash?
Well, in the visualization I showed you, I was looking at how the signal performs during a normal day. I think I went like the week before the crash happened, and I said, let's see how this signal performed. And then I looked at the day the crash happened, how did the signal perform? And the thought is that State Highway could then use that to go out and say, okay, do we need to adjust our signal timing plans for when there's a special event? Because they already adjust their signal timing plans for when there's when there's significant events, but they didn't expect, they didn't expect it to perform the way it did. So this is giving them insights into that performance without having to send someone out in the field. Does that make sense?
Yeah, that part makes sense. I just was wondering if what you showed is that the already pre-timed signal
No.
to an event.
I don't know if they actually implemented the plan or not, because to be fair, the closure, while impactful, it was only 4 hours, and that seems like a long time if you're stuck in a crash, but many DOTs don't go and actually change their traffic signals until it's a 6 to 10 hour type of a closure. So we're not sure what they actually did there.
So during the pandemic, we saw that crashes and deaths went up. Do you have any insight from your data about why?
I haven't looked at that. I mean, there might be insights in there. My guess is that people are driving faster because there's less congestion, but I don't know that.
Okay.
Yeah.
Any other questions, thoughts?
I have a question, but it's back to Linda. I don't know if I can ask it right now.
Sure.
So I wanted to just ask real quick, especially when they were talking about the data when you put it in a dashboard, I wanted to know the same thing about insights within the dashboard. So for example, what I do is collect all the crash data in the state of Louisiana, and we try to go to different departments and try to get access to their data. The one thing I always hear is we know our problems. And so when you try to create a dashboard, either they say, yep, we knew that already, or they say, no, that was insight. So for example, they'll always say, we know speeding is going to occur on the state routes, or we know it's not going to be in the mornings because that's where traffic jams are. So we know it's going to be when there's not a lot of congestion. So we already know they're speeding there, and we already know what roads it is. So my question to you is, when you did all this work, were there a lot of insights, and were the people like, oh, I did not know this, or was it more like, well, we already knew that, and then so I was just curious how that happened, because usually when you can show them those insights, they get really excited and they want to share more. Otherwise, they're like, no, I already knew it. So I was just curious in your findings.
Should you come up to the microphone?
Yeah, definitely. I could see there being both cases, specifically with Henderson. Luckily, with the people that we spoke with, they were able to work pretty well with us as far as they essentially just wanted us to be able to help them. And their response was, well, we have all this information that we don't know. So they kind of admitted that, we don't know what we don't know is what they said. But I can certainly see other agencies being like, well, I've worked with this system for a really long time. I know it. I already know where all the speeding cases are. I don't really think that we need to necessarily change things. And that's actually another issue, not necessarily with this project, but in other projects where there's a reluctancy to change that we see between agencies. So that is another issue in which, as one of the points I mentioned, is interagency collaboration. The reluctancy to change, we want to be able to see if we can work together so that way when we implement new technology, we can be more convincing of having these people work in departments and be accepting of this new technology. So yeah, I don't know if that kind of answered your question in regards to that. And of course, different agencies work differently. So I'm not sure, how your agency works exactly. But luckily, with the systems audit that we did for all the systems, part of it is just kind of sitting down individually with each of them, and that kind of gives it more of a personal experience as opposed to a whole conference where everyone's kind of being put out there, out in the open. So maybe that's the suggestion that I would have, is kind of having these departments sitting down with them individually first before meeting with all of them as a whole.
level, and who should invest on this knowledge? Where should this kind of visualization of the data lie? I might know your answer, Michael, to that, but sort of, there's a learning curve to this as well. And so if we are doing this every city, every agency at a time, or is it more like concentrated one? What is your views on where this can work in investment?
So I feel like there's a lot of reinventing of the wheel going on, and it would be cheaper for everyone if we pooled our resources together and invested in something that would do the basics for everybody. Now that something is not going to meet everyone's needs. There's always going to have to either be customization or local development that occurs to do whatever the locals need. But I think there's still lots of cost savings to be had if we invest our resources together.
So I would agree in that sense of interagency collaboration, both at the federal, state, and local municipalities. Actually, one of the issues that we found is, so autonomous vehicles are abundant. The technology is emerging faster than ever. And one of the issues that we found with that is, or one of the issues that the developers of these autonomous vehicle systems are having is the ethics behind it. So who's responsible for whenever there's a crash? And the issue with that is the responsibility of the roadways, or the ownership of the roadways, is actually not at the federal level. It's actually based off of state and local level, the cities. So the cities own or have ownership of the roadways, and so when they're mapping out the infrastructure of the autonomous vehicle systems, the problem then becomes, well, who's responsible? You know, are we programming it based off of the state level, because that's technically the law of how it's currently written, or should we build it to where it's a central system and all the code is essentially the same throughout the entire network, which ideally is the case, but currently how our legislative laws are made up, that's not the case, so that makes it difficult. So to add on to that, something like a dashboard analytics, the ideal case scenario is to be able to build it so that it's uniform all throughout, a standardization at the federal level, but that has to be adopted uniformly throughout all jurisdictions, and that part is the most difficult part.
I'm looking at the audience if there are any further questions or comments. If not, I think I guess at the back there.
So I just wanted to make a comment. How you doing, Mike? I'm Ramon Robinson. So I like the idea of the uniformity, particularly if you're talking about the location-based survey data and how that's able to be used. Because I think for most municipalities, MPOs, probably some states too, you know, in the way that they're trying to formulate their travel forecast models, right? Everybody's looking for different ways to be able to acquire the data to put the inputs in. And it seems like this is that evolving technology, right? That it's a little bit different. Do you see that as something that is going to be what moves forward?
I don't know. Sorry.
That's a bit boring question. So, for Michael, for the connected vehicle data, do you pull them together? I mean, do you put all the data from different providers in one big pot and you do your things? Or do you only rely on one source?
So it depends on our client. So the Cat Lab doesn't own any data, right? We are taking data that our clients are purchasing for us. So if a client buys data from one provider, then we will have only data from that one provider in the particular tool. Now that one provider may be sourcing it from lots and lots of other providers. But we do have a few clients that buy data from multiple sources. And when that happens, we blend them together, and there is a problem with deduplication, because the business is very incestuous, right? There's companies that buy data from each other and then resell back to the public, or they might have the underlying data sets might come from the same OEMs or the same cell phone providers or the Facebook or the flashlight app that you have on your phone. And so we have to try to find similar trips. When I say similar, I mean identical trips. And we have to remove It creates a barrier if you're trying to do national level analysis.
Don't you do national level analysis?
There's very little national level analysis we do because our clients are mostly the state DOTs. There are a few data sets that we have there at the national level, but those are few and far between. We want to do national level analysis for national level policy making. I think there are some ways to make it work. Like, let's pretend all 50 states came to me and wanted to work with me, and there were, let's say, 7 different data providers that each state had bought one of those 7. I think there's a way we could still make it work, but there'd have to be a lot of caveats and claims we'd have to make for the feds doing national level analysis. Like, the states would still be fine, right? But feds would not.
Have you used data from Replica, the Google data set? Have you used it for anything?
No. So the Replica folks, is there anyone from Replica here? So Replica has a fantastic front end. They've got really, really cool visualizations. I love what they've done. I will probably borrow from some of their ideas. My issue with Replica is that it's mostly a model data set. And a lot of our clients, including myself, I want to see raw, real, measured data. And then I might use that to inform my model, but I don't want to inform my model from someone else's model, which is informed from other stuff. So it's not my cup of tea, but for cities that want to do true multimodal stuff, that might be the best thing out there for the short term. I say short term, I mean like next 6 to 9 months. They also have, there's a startup time, right? They have to go in and calibrate the models every time. I think while Replica works well for cities, I don't think there will ever be a national Replica, right? I think that's going to be very tough.
I actually have a question for you. So, a lot of the work that I mentioned, at least doing for the city of Henderson, was, system integration. And I know that you pulling in data sources from multiple states. Were there any issues or challenges that you found pulling data sources from different people, vendors, and systems from a data perspective, integrating it into your existing system?
Especially if there's overlapping geography. So like, let's use Florida as an example. So Florida has lots of districts, right? Each district has their own ATMS platform. Now it's based on one statewide platform, right? But they each have different versions of it deployed at any point in time. And so they're going to have duplicate IDs, and they might overlap geographies very slightly, so there's problems there. But then, if you're comparing what's happening in the district from their ATMS platform to like compare dispatch data that you might get from local police or state police, there's going to be conflicts. They might classify data differently. Same thing goes from data providers. Enterx here in TomTom all say that they provide their data on a common standard TMC, traffic message channel schema for representing the roadway, but everyone's implemented a slightly different version of that TMC standard, so it's not really standard anymore. So it's tough for agencies to switch vendors once you've spent a number of years investing in one. But we could talk about data issues for weeks. So many things.
Yeah, problems with being a data scientist.
I'm just not familiar. Is this becoming a lot more cost effective now, gathering data like this than the traditional go out and put tubes?
For speed and positioning, it's way more cost effective than traditional methods of installing sensors or putting cameras out for license plate recognition, and it's ubiquitous. You can get it almost everywhere in the country. It doesn't do everything though, right? These third-party providers don't really it's certainly less expensive than deploying your own infrastructure.
All right. Thank you for both of you for excellent presentations. I hope you all learned something and got away with some new insights. I did for sure. So thank you very much for the presentation.
Thank you, Yari, for being a good moderator.
We have a few more minutes before the break.
I'm doing all right. What's good? Michael already. Ramon, nice to meet you. No problem. You're in Houston? Uh-huh. All right. From Houston. What part? I'm trying to think. I know Houston. Veronica? Yeah, she went there. She was up here. Data consulting. Yeah. I was like, yeah. So what, no, you
left their charger